Welcome back everyone. Today our lecture will be on differentiation, the second part of the lecture series of calculus of class 11th for IITJEE and NEET. Okay. Now, for learning differentiation and also discussed a bit of differentiation in the previous lecture. First, let us recap all that we have learned in the previous lecture, right? So first of all, before learning differentiation, you need to understand number one, rate of change. Right? You need to understand what is rate of change. Now once again, before understanding rate of change, you need to understand what is change. Change is basically when a value changes from one to another, right? For example, the value of x changes from its initial value to its final value, that is xf, right? So what will be the change in x? Change will be final value minus initial value and we represent it by delta x, right? Similarly, since now in differentiation we consider one thing, we consider that y is a function of x, right? In last class I had also told you what a function is, that is corresponding to a value of x you will get a value of y, right? For example, you can have a quadratic function like y is equals to 3x squared plus 5, right? So this is an example of a function. You will learn functions in detail in mathematics, right? Now, y is a function of x, so corresponding to the change in y, that is delta x, the change in, corresponding to the change in x, there will be a change in y, that will be delta y, and we can write that as y final minus y initial, right? This is a change in x, this is a change in y, and why did y change? Because y varies as a function of x. Now, you understood what is change. Now it is time to understand what is rate of change. Rate of change is nothing, it is simply change in y with respect to change in x. That means we can write it as delta y by delta x, right? Change in y with respect to change in x. Now in differentiation, the main thing that you need to learn is instantaneous rate of change. What is the term? Instantaneous rate of change. What does that mean? This basically means rate of change at an instant. And how do we represent it? We represent it like this: delta y by delta x, where delta x tends to 0, and when the change in x is very small, then this whole expression can be written as dy by dx. Change in x we wrote it as dx because it is very small. Last class I told you that what is dx? It is called differential of x, which is a very elemental change in x. And since y is a function of x, due to the small change in x, y have also changed by a small value of dy. And that is why instantaneous rate of change we can write it as dy by dx. Okay. Now also in last class I told you that how can something change at an instant? Instant is a single point of time. So how can something change? I had given you the example of a bus, right? If someone asks you in speed of the bus, comes and asks you that what is the speed of the bus at 11:30, let's say. So how could you say? Because the bus needs some time to travel a distance. You will mark the distance and then you will divide it by the time it has taken to cover the distance and get the speed. You divide the both and you get the speed. But if someone asks you at an instant, time is 0, time interval is 0, then how can you find the speed? Actually, time interval is not 0. By instantaneous, we keep something hidden, and that hidden thing is dt in this problem. Actually, when someone comes and asks you instantaneous, that means he's asking you to find the speed between the interval t is equals to, let's say, 11:30 am to t is equals to 11:30 am only plus dt, which is a very small interval of time. That means 0.00, many zeros, infinitely many zeros, and at the last a 1 maybe. So that much interval of time. Now this is almost negligible, so we tell that it is instantaneous speed of time. But basically, instantaneous rate of change. But basically it is having some interval. Here time interval is what? it is dt, and since dt is very small, we call it as instantaneous rate of change. So this is a very good example to understand instantaneous rate of change, right? Note them down. Now once you get this time interval dt, you can now find the speed, right, by distance covered upon change the time interval, right? What is the time interval here? It is dt. Write it down. And what is the distance covered? Time interval is very small, so bus will also cover a very small distance in dt time interval, and hence we write it as ds. And then you get the speed of the bus, right? Instantaneous speed. Okay. Now we'll basically discuss a method to differentiate without using formula. Many of you might know the formulas and they will be given in your book as well. But learning differentiation without using formula, it's a good thing to know, right? So let us see with an easy example. Let us say y is equals to 5x plus 3, right? It is a simple linear function, and it is given that the final value of x is the initial value of x plus delta x, where delta x tends to 0, and so by your logic you can say that final value of y will be initial value of y plus delta y, where delta y tends to 0. So you can write delta y and delta x as dx or dy. So let us do so. So y is changed by a very small value of dy, x is changed by a very small value of dx. Okay. Now, someone asks you, means the question says, find dy by dx. What is the value of dy by dx? You can simply use the formula from this expression and get the answer. But let us solve it logically. Now see, x is changed from xi to xf and the change is dx. So, can we write 5 into x plus dx plus 3 and here y plus dy this side. Now why did I write this equation? So let us say the initial value of x was x only and the final value of x was, let's say, x dash. Now since it's a function, it will be valid for both the initial and final values of x, because if y changes to some extent, x will also change. Sorry, x changes, then y will also change. So this is basically the expression that we wrote for the final value of x and y, right? This expression is valid for final value of x and y also. So change in x is dx and corresponding change in y is dy. So y plus dy, final value of x, is equals to 5 times the final value of x plus 3. Final value of y, 5 times the final value of x plus 3. Now let's solve the equation further. Y plus dy is equals to 5x plus 5 dx plus 3, right? Let us do one other more step. Y plus dy is equals to 5x plus 3 plus 5 dx. Now could you see these two things? In the initial expression y is equal to 5x plus 3, so you can cancel them out. Y and 5x plus 3 are equal, so we can write dy is equals to 5 dx, and then we get dy by dx is equals to 5, right? So this is the basically method of solving, not using formula, right? So note them down, and now we will see the formulas related to differentiation, the trigonometric formulas, then exponential formula. Okay, note them down. So we are back with the formulas for differentiation. First one, y is equals to x to the power n, then dy by dx is equals to nx to the power n minus 1, right? This basically means that if in the expression of dy by dx you put x to the power n means dy by dx is equals to dx to the power n by dx, then you will get nx to the power n minus 1, right? This is the formula. You can directly use them. Second is y is equals to e to the power x. When you differentiate it, you get e to the power x only, no change. Next is y is equals to ln x. This basically means log of x to the base e, right? Base is e, and here you can write log x to the base e as ln x, right? And when you will differentiate it, you will get 1 by x. Now comes trigonometric functions, right? So under trigonometric functions, you have y is equals to sin x. Differentiate it, you get cos x. For cos x differentiated, you get minus sin x. Remember the signs. I will also tell you a trick how to remember what sign where. So cos x you differentiate, you get minus sin x. Tan x you differentiate, you get sec square x. Cot x you differentiate, you get minus cosec square x. And if you differentiate a constant, you will get 0. Now what is basically differentiating a constant? Y is a constant. Let us say with an example, y is equals to 5. Y is equals to 5, right? This is a constant value. Y is not depending on x. But someone can write 0 into x, add it with 0 into x, but that doesn't matter. Y is a constant, so y doesn't change. And so, if y doesn't change, then rate of change will always be 0. That is why dy by dx is equals to 0, and hence you need to remember that constant's differentiation is 0. Now, how do you remember the differentiation of trigonometric functions? First of all, how to remember the signs? You see, wherever there is co, there after differentiating you are getting a negative sign. See, y is equals to cos x, you differentiate, you get minus sin x. You differentiate cot x, you get minus cosec square x, once again negative. So wherever there will be in co, you will get minus sign with the value that you get after differentiation, right? Second thing, sin x and cos x is easy to remember, that sin x will be cos x and cos x is minus sin x. But how do you remember differentiation of tan x and cot x? See, in trigonometry you know an expression, rather an identity, that is 1 plus tan square theta is equals to sec square theta, right? You all know this. You must have learnt in class 10. 1 plus tan square theta is equals to sec square theta. So, like in analogy, you can say that if tan x is there, differentiating you will get sec square x, because they both are related in an expression or an equation like this. Similarly, you know that 1 plus cot square x is equals to cosec square x. Cosec square x, right? This expression also you know. So from these two expressions, it's just a way to remember, right? That if cot x is there, cosec square x will come, and sin, you know, if co is there, negative will come, right? So this was basically the formulas for differentiation. Two more formulas for differentiation are there under the trigonometry list. You must have noticed, that is 1 by cos x, that is sec x, and 1 by sin x, that is cosec x. I intentionally skipped those, as after reading a rule I will make you people derive that formula by your own, right? So till then, thank you.